So you've got this great scientific idea for a great research project. You're excited about the science, excited about engaging with new people, colleagues, and now you need to start a grant application. And how are you going to go about that? What do you need to do? What task do you have to complete? How long is it going to take? And how much is it going to cost? So to help you, there is a very good tool which is quite simple to use and very comprehensive at the same time. It's called the critical path analysis, and that's what we are going to talk about today. In this tutorial, we will cover the basis of critical path analysis. I will use a simple example to take you through it step by step. I will also show you how it can strengthen your funding application and how later on it will help you manage your research project. We'll also talk about the common mistake that you can make in project planning. First, let's look at what critical path analysis is. So critical path analysis is a project planning and method that will help you in many ways. First, it will help you identify the essential tasks that are required for the successful completion of your project. It will help you determine optimal timelines, and it will also show you where there are areas for flexibility regarding the timelines. It will help you identify potential risks that could compromise your project, help you allocate resources, determine priorities. It will also help you later on to monitor the progress and the success of your project. It's also a very good communication tool, and if you use it well, it can show the funder that you know what you're doing and how you're doing and increase your chance of success. Let's start by defining what is the critical path. The critical path is the sequence of tasks or activities that determines the minimum time required to complete a research progress. Any delay in executing a task or an activity that is on the critical path will impact the total project duration and may lead to failure to complete your project. What are the key characteristics of the critical path? The critical path shows activities that cannot be delayed without delaying the entire project. It helps you identify tasks with no scheduling slack or buffer time. It also identifies dependency between different project activities, what needs to happen and in what order. Very often it is a visual representation. It is a network diagram or a Gantt chart, and we'll come back to Gantt chart later on. It has other benefits. It will help you focus on what is most important to complete in your project. What are the key activities that you need to complete to be successful? So why is it important for funding application to do a critical path analysis? First, because it demonstrates that you have done a rigorous planning of your research work. It makes the project easier to understand for a viewer. It shows that you will be able to manage complex international partnership. It also shows that it is feasible to do what you are proposing to do. It also shows to the reviewer that you understand the different phases of your project and that you will be able to deliver on time and on schedule. It can be helpful to identify milestones and to track them. It helps you identify clear checkpoints for progress reporting to the funder. It's a good tool to justify personal, equipment and budget requests in your grant application, and therefore resource management. And it will also help you with risk management, anticipating the problem that could occur during your project and how you're going to resolve them. Now let's look at the different steps to develop a critical path and then conduct the analysis. First, you will need to break down your project into tasks or activities. Second, you will need to understand or define or identify dependencies between these different tasks. What needs to be done first? You will be estimating duration, then build the diagram, identify the critical path from the diagram, then analyze and see if there are places where you can optimize your research timing. At the end, you will review and validate and include the outcome in your grant application. Step 1, breaking down the project into tasks or activities. To do that, it's very simple. List the main activities of your project. You will not get all of them in the first attempt. It's an iterative process. As you list activities, more will come to mind. You may sometimes subdivide these activities into more manageable tasks. You need to be precise without being overly detailed. We won't at this stage go into too much detail. You need to be sure that you have the key activities that needs to be performed. Then you will come back to that and you will go into more detail. we are going to use a simple example of a PCR analysis. Let's say you'd like to determine the expression level of a recently identified gene that may potentially be involved in metastatic process in tumor samples. So your main activities will focus around performing PCR experiments. You'll need the methods for that. You will also do some data analysis. Your aim is to do a publication and thinking about what else you need, some samples, and of course some primer and maybe a PCR machine. So having identified the major tasks, and again, this is an iterative process, you will come back to this during the construction of the critical path, you need to determine if there are dependencies between these different activities. There are dependencies between activities when the completion of one activity rely on the completion on the other. There are different types of relationships between activities. For example, finish to start. Task B begins when task A is completed. Start to start. Task A and B can start at the same time. Finish to finish. Task A and B ends at the same time. Here are some examples of dependencies. Finish to start. Ethics approval for a clinical study must be obtained before starting the recruitment of participants. Start to start. A literature review can be done at the same time as you are developing the protocol. Finish to finish. Data collection and database management usually end together. So let's look at, for example, of a PCR analysis. First, you will probably do some dry bench research, trying to identify the protocol to do the PCR. You will probably need to buy some primer and maybe some piece of equipment. You also need to collect samples if you don't have them already. You will need to perform some RNA extraction, run your PCR after having developed and tested your protocol, and then analyze the data before doing some write-up and submitting to publication. There are more steps involved, and as you will see, you can figure them out as you develop a full Gantt chart. In step 3, you need to estimate the duration of the various tasks and activities you have identified. Usually, this is based on previous experience. Because you have already done this type of work, you know how long it's going to take approximately. If you do not know if it is something new, do not hesitate to consult with colleagues who have done something similar and who can advise you on how long your particular task or activity is going to take. It's important to be realistic and somehow or somewhat precise. You can come back to that at a later stage. It's good to know from the start how long it takes to do a particular activities. Do not hesitate also to include buffer time for unexpected delays that you haven't foreseen. And importantly, don't forget administrative timelines. They are sometimes quite longer than expected and can really slow down your project. So here are some examples of common research timelines. A grant application, a small-scale grant application, could take 1 to 2 months of dedicated work if you really spend a lot of time on it. Ethics approval between 2 and 6 months. Note that it is not something under your control. So here too you need to include some buffer time. Patient enrollment in the clinical studies, think about a period of time and multiply it by 2 or 3. Here it all depends on your previous experience in the field. Are you already working with the community in which you are trying to recruit from? Have you worked or set up a community advisory board? If you are completely new to the situation and the settings, it might take longer than you think. If you're already involved with the people, it will go probably faster. Equipment procurement between 1 and 3 months. Here too it depends where you are based. It depends if you have to go through custom, how long it takes to deliver what you want. Animal protocol approval, anything between 2 to 4 months. Again, this may have to go to some internal committees or ethics committees. As for manuscript preparation, between 2 and 4 months. Here also it depends how many people are involved. There can be a lot of back and forth, and therefore it's going to take maybe longer than expected. Article revision, assuming your paper has been accepted for publication, anytime between 3 and 9 months. It depends on the scope and the extent of the revision required. Don't forget that if your paper is rejected, you will have to resubmit and your timeline is going to be extended. So let's look at our PCR example. If you think about the equipment, primer and other regions, how long is it going to take to get them? You may need to require some quotes. The order will need to be processed. They may be stuck in customs, so it's very variable. For the methods, maybe you are an expert in PCR and you will quickly get it to work, or it may take longer. As for the data analysis, do you have statistical knowledge, or will you need to call on the help of a statistical services? For sample collection, you may already have the samples, or you may need to set up a collaboration to get them, which means, again, having to go through ethics. So as you can see, as we start thinking about the duration of each of the tasks, we also start to identify new tasks, and these will need to be included in the diagram that we are going to build next. So for building the diagram, as a reminder, we are going to use a visual representation of the various activities and tasks, and we are going to find if there are some interdependencies between these activities. We will then start to identify if some tasks can be done in parallel, and that will lead us to identify parallel path, and we will then start to calculate the total time required. Again, this will be an iterative process. So to build the diagram, I recommend you use some tools. It could be very simple tools like paper and pen, like Post-it, or you can use some software that are specialized in producing Gantt charts or project management software. Importantly, choose something you are comfortable with. If you have to spend a lot of time learning how to use the tool, this is time you're not spending on writing your grant application. So sometimes pen and paper, Post-it are the best. Start with major milestones. You will already have identified them, or you will identify them as you build the diagram. Color code different project phase, for example, the preparation phase, the experimental phase, the analysis phase. This will help you better visualize what you have to do and when. Include key decision point where the project direction may change. That's often related to the milestone themselves. Then it's going to be time to identify the critical path. You will need to determine the earliest and latest start date of each of the tasks and activities. You will need to determine if there is some flexibility in the time you have allocated to each of these tasks. Document your assumption. What makes you think that a particular task will take a particular time? Where does the flexibility come from? Identify tasks which have no margin. They must be completed in a particular length of time. As you go through that, also mark critical tasks clearly. Again, use color coding or any other formatting that helps you identify these tasks. Focus your monitoring effort, and by that I mean these are the zero slack tasks that need close attention during the execution. Identify also near critical path tasks. These are tasks that are not on the critical path, but that may also impact the progression of your project. And ultimately, you will be able to determine the critical path, and we're going to do that with our example. So to build our Gantt chart and perform our critical path analysis, I'm going to use an app available online called Team Gantt. It's a free version. It is limited by sufficient to do one project at a time. So a quick tour of the interface. Here on top you have the calendar with the month and the day. This can be changed here in the zoom function. We will look at color coding task here. There isn't much else you can do, but we'll go through it. As you can see in this example, and as I mentioned in the beginning, I have already identified key activities in my PCR project: procurement, development of the methods, analysis of the sample, analysis of the data, and publication. The gray bar you see here is the sum of all the tasks for each of these activities. So for each of these activities, I went into a bit more detail on what tasks are involved. For example, in the procurement, I need to procure a PCR machine, primers, and reagents. For each of these, I have already estimated here the time that I needed to complete this task, because it's going to go through the quote and then ordering and then delivery and so on. I think that I could have my qPCR machine, we're thinking about quantitative PCR here, within a month, and this is the size of this bar. I could move it. If I'm more optimistic, I would say 3 weeks will be enough. If I'm more pessimistic, because I have to go through custom, for example, I will extend it. So here again, it's about estimating how long it will take to get a task completed. For the primer, it's the same thing. I think by the time I send an order and I get them delivered, it should take about 2 weeks. Again, I could change that depending on my own setting. Common reagent, I have them. I just need to check that they are all there If something is missing, I will need to order. As I did that, I also identified a first milestone, which means when I have completed all the procurement activities, I will decide that this is a first point in time that is important in my project, and I'll put it here. This is completion of all these activities. Now the dependencies have not been identified, and I will come to that. For the development of the PCR method, I think I will need to do some cell culture, which I will use as reference to develop my PCR, need to do some DNA extraction from these cells, develop the PCR, and when I will have completed all of these activities, I will have reached a second milestone. Here again, I've used different color coding for these activities. Green here, blue here. Again, the dependencies are not identified, and the estimates are based on my personal knowledge. I will then perform the PCR on the tumor samples. I think it's going to be easy to collect the samples. I've already have a collaboration with someone, so I think that within a month, I will be able to get all the sample I need. I've identified what I needed. These samples have already been collected, and I might just need to get some authorization or approval from the person who owns them. The DNA extraction here is estimated over a period of 4 days. For these 40 samples, I may not want to do them all the same day. And I will do the qPCR in 2 batches here. And again, when I have completed all of that, the technical work will be done, and therefore I will have reached a new milestone. The data analysis will be much easier. I think it's going to take me about a week, so let's put that at a week. And when I've done all this, I will be able to write up a paper and submit it for publication. Here, as you can see, I can start the publication from the start if I think about the introduction section, for example, or gathering the references and so on. So what we have done here is simply to identify high-level activities, and for each of these activities, we have identified tasks, and for each of the tasks, we have identified a length. Now we need to put that into order. So if I'll go back here to the top, I will start by the procurement. These 2 tasks, procuring the PCR machine and ordering primers and reagent, can all be done in parallel. I could actually start all of them at the same time in parallel. On the first day of my project, I could go in the fridge and check what I have. I could go online and order primers and find a PCR machine and so on. So I could leave it like that for now. And I'm going to say that I'm going to link the longest one to the milestone here. So now, if this takes longer, and this is what this software are quite useful, for example, if this takes longer, you can see that my milestone is moving in time. It's connected. These 2 tasks are interconnected. So let's go back to a month for that. I could decide that, on the first day, I'm going to focus on the qPCR machine. I'll order that a little bit later in the month, and that's fine. But I still need to check the region quite quickly to make sure I have everything, and so I can do the order all together. So I'm going to leave it like that. To reach this milestone, I need to have the qPCR machine, but I also need to have the primer. So I'm going to link the primer to the milestones. And I also need to have all the other reagents, and I'm linking these reagents to the milestones. So now, as you can see, if there was any problem with the delivery of the primer, and if it would actually take longer than delivering the PCR machine, what's happening is that my milestone is being pushed back in time. The length of the project is already starting to increase. So this is why these tools are quite useful as a visual presentation. They show you the impact of delays. So let's bring that back here. For the development of the PCR, I can do cell culture and DNA extraction together at the same time. Do I want to do that as I am already ordering PCR machine, primer, and all of that? Maybe not. I'm going to wait a week, and I'm going to just push that back at the second week here. For the DNA extraction, obviously, I can't do it if I do not have the cell culture done, so I will push that after the cell culture. I'm assuming it takes me 2 weeks to get enough culture of cells. I'm not going to do the DNA extraction for Monday. We have a lab meeting on Monday morning, so I can't do that immediately. And when I have the DNA extracted, I could start immediately the PCR development. Again, I'm going to link the cell culture to the DNA extraction. I cannot do DNA extraction without cells, and I cannot do PCR development without DNA. When I have done all of that, I will have reached my second milestone, and I'm going to link my milestones to the last activity here. I could also link it to the DNA extraction and cell culture. What happens if, let's say, cell culture don't go well, they are pushed back in time. As you can see, everything moves. So again, we see the impact of delays on the timeline. For the samples, as I said, I already have a collaboration with someone who has collected some samples. I could actually reach out to them as I am working on the procurement here on top. Once I have all the samples, I will be able to do the PCR, the DNA extraction, and once I have the DNA extraction, I'll do a first round of PCR, a second round of PCR. So here, when all of that is completed, I will have reached my third milestones. I need now to consider interdependencies. Sample collection is not dependent on the other activities we have described before, but neither is DNA extraction. But I need the sample to do the DNA extraction, so I'm going to connect the two. To do the first batch of PCR, I need the DNA, and same thing for the second batch. And when I've done all of that, I'm going to connect this first batch of PCR, this second batch of PCR to the milestone. Let's look at the analysis. Obviously, for the data analysis, I need all the PCR being completed. So I'm going to link this milestone to that activities. And to submit the paper, I need to have done also all the analysis. As you can see here, the link appears in red. As you can see here, the link appears in red because obviously I cannot submit if I have not completed the analysis. Therefore, I need to push my analysis. I need to push my submission later. And I'm going to connect this activity to this one and extend it a bit. So, according to this timeline, it's a very short project. We are less than 2 months. Let's see what we could do to slightly improve it. We could definitely shorten maybe some activity. We could collect the sample faster. Let's say we'll have them in 2 weeks. That's one thing, but as you can see, it has no impact on the overall project because to do the PCR, I first need to have developed the method. So there is no real point in trying to shorten this. So I'll bring it back to a month. What would be useful is if I could develop the PCR faster. And again, I could develop the PCR faster, but it doesn't impact much the project in the sense that I would need to have all the equipment. And this is where, as you can see, I didn't link reaching that milestones to these milestones. If I had not done that, I would have misplanned, in a way, my activities, thinking I can do the PCR, but I don't have the equipment. So now I have connected this milestone to this one, and you can see it appears in red. Therefore, I need to push that here. And this would bring everything back in black. So we are fine now. So the only way it seems I could shorten my project is if I could get the PCR machine faster, because that would definitely have an impact. But again, it means I also need, in this case, to bring my sample connection in line with that. So it really shows you how things are connected and how they work one with another, what you can do and what you cannot do faster. So here, let's bring back that here. Cell culture is here. We are fine. We can do the DNA extraction. We can do PCR here. We can collect the sample. We can do the DNA extraction, and then we can do here the PCR on these samples. What could happen is, assuming that you were on leave or there was something like, say, we are not covering Christmas here, but if it would take longer, you could easily imagine that there is a period of holiday, and that this period of holiday would have to be included because nothing happened during this period. So let's think about it, or rather let you think about it. So this is how you can build your Gantt chart. color coding different activities, C, identifying milestones that are critical to the progress from one stage of development to another, and identifying the critical path. So the critical path appears immediately is the connection between getting the equipment here to getting the PCR being developed to here getting the PCR being done on your sample, and then your analysis and your publication. You can then play around with the time needed and everything else, and this is really something to help you thinking. Now with this app, you can also click on each of these activity here, and you can add more detailed. You could add comment. This is where you could potentially document your assumption. You can change the color. You can identify the predecessor and the successor. You can even store information. For example, if you have a quote, and here it shows you the change you made before, so you have a history of change. So it's quite a good software. It's a shame that the free version comes with only one project at a time, but there is plenty of option here. You could explain the change you have made. You could leave comment for someone else if you work as a team, or why you have made some decision, or what needs to be done, or what you need to account for. So it's quite powerful and quite useful. So we now have completed the critical path analysis, and we have a beautiful Gantt chart. It's not over. We can probably optimize the Gantt chart. There are various ways you can optimize your Gantt chart, starting by some basic optimization strategy. You could try to shorten the non-critical task. You focus resource on activities that directly impact the total project duration. Tasks that are not critical, you will give them a little bit less attention. But again, don't completely ignore them. You can try to parallelize activities, that is, run independent tasks, that is, tasks that are not interdependent, simultaneously when this is possible. That may require more resource or more people. It is up to you to decide if this is possible. Advanced optimization techniques include negotiating flexible deadlines for non-critical tasks to create buffer time, building learning curve by allowing extra time for new technique or methodology, and finally, consider outsourcing option for analysis or services that could accelerate critical tasks. This is for things that you're not an expert in. Maybe someone else can do it for you. So all this being said, what are the other practical applications of the critical path analysis for your funding application? In the project summary, for example, you can use the milestones you have identified to structure your abstract, and you will build your abstract around each of these milestones, describing the project step by step on the basis of your milestones. You can highlight key deliverables and their timing, because you know that from looking at the Gantt chart. Use it also in the methodology section. This will help you presenting a very realistic work schedule that should convince the funder. It also helps justifying the total duration of the research project. Sometimes the funder may think, well, you are too optimistic, or on the contrary, you are too pessimistic. But this shows the funder that you have really planned and scheduled the various activities and how they are connected one to another. It will also help you explain the major milestones and why you have chosen them. In the budget section, it will help you justify your request for resource, whether it's staff, equipment, or any other things you have identified from building your diagram. At the end of the day, it clearly demonstrates that you are using the fund for the best of the project and the research. There are also practical applications in the risk assessment section of your grant application. The Gantt chart will help you identify critical tasks that could delay the entire project. You will then be able to propose contingency plan. In the impact section, you will be able to link publication and dissemination to critical path endpoint, very often the milestone. It will show that you have maximized the timeline to improve the research impact. In the collaboration section, if you have to describe collaboration, it demonstrates how partner will contribute, when and where. And it shows that you're able to coordinate the management of numerous activities across numerous institutions. So now, what are the common mistakes to avoid? Excessive optimism, systematically underestimating duration. This is something quite common. Everything can be done very quickly. We have the expertise, we have been there before, we know how to do it. It's often more complicated than that, and there are always some spanner thrown in the work. Again, think about what happened with the COVID. Think about what happened at the custom if you're relying on equipment and reagent. Think about what happened with community engagement if your research is not well perceived and if you have not engaged with the community. Often ignoring the administrative delays, whether it's ethics approval, recruitment of staff, specialized staff in particular, but there are all kinds of delays that are purely administrative. You may have neglected dependencies, in particular external dependencies, if you rely on collaborators, on supplier or ethics committees. How did you, or more importantly, how well did you factor that into your timeline? You may have made some assumptions that were not warranted. For example, immediate availability of equipment, lab space, supervisor feedback. Don't again be over optimistic. And you may also have overloaded your schedule, trying to do too much in parallel, too many things at the same time. So suggested that you may be able to do things in parallel, but you can't do everything in parallel. And again, it's all going back to being over optimistic. Also, not planning for skills development, particularly if you have to learn a new method, new tools, or new software. And again, I go back to the use of software for actually doing the critical path analysis. You may spend a lot of time on that. You may spend much more time in, for example, on developing the PCR method because you have never done PCR before. So you need to have a clear understanding of what you, but also your team, is capable of delivering. And if you need to bring in external people, or if you need some training of your own people. And ignoring deadlines, for example, of conference or publication deadline, you may miss a strategic submission, underestimated revision cycles, whether they are your own grant application or a manuscript or any other things that require involvement of other people. Omitting time for reflection and analysis. Research is not linear. As you develop your proposal, you will get more ideas, or you will refine your idea, or you will change what you plan to do. This requires some time for you to think. Just don't rush. Don't again overload your research proposal. Be realistic and spend the time really to think about what you are doing, why you are doing it. Forgetting vacation and conference time, both yours and your collaborator. The summer months tends to be rather quiet as is the end of the year, and this can seriously impact your planning. Finally, key question you need to ask yourself when doing your critical path analysis. Can you clearly explain why each task is necessary? Have you identified all dependencies? Are your time estimates realistic? Have you consulted with experienced researchers about your timeline and your activities? What are your highest area for risks? How do you manage these risks? Do you have backup plan for bottleneck? Can you shorten your critical path? Are your milestones measurable and achievable? And I will do a separate video about this. Does your timeline align with the funding period requirement? Funder may provide funding for a specific period of time. Does your timeline fit with that of the funder? Have you accounted for your own learning curve, skill development, and that of your team? Is your plan convincing to an external evaluator? Be very critical with yourself. So this is all for this tutorial. I hope it was helpful. If you have questions or comments, please post them in the comment section. I'll try to address them. I can always be contacted by email if you have a specific need, and if I have the time, I'll be happy to help.